Hello, Marauders, and welcome back. You guys did very well on the geometry test last week, and there's a lot more to geometry than what we just did. You can actually do an entire year of geometry, but that was some of the basics of it. It was pretty fun, but now we're going to be doing some Math 2 stuff. This week, we're going to do the Pythagorean theorem, named after Pythagoras, one of the most famous theorems of all. It's 2,500 years old. It goes back to the Greeks, and we'll learn about radicals, in other words, square roots. And when you start Math 2, one of the first chapters they're going to do is radicals. But the way they explain it's going to be kind of weird. And I suggest you do it the way I explain, which is the college way of doing it. They're going to show you this bizarre way which makes no sense. Do it the normal way that college students do it. So you definitely don't want to miss out. And here's the plan for the week. Monday we'll do today, Pythagorean theorem. Tuesday we'll look at a special type of triangle and how to do a shortcut for the Pythagorean theorem. We'll also learn about radicals. Radicals is a fancy way for these guys, square roots. Wednesday, more about radicals. You could do a whole unit on it. And Thursday, we'll do the test. Why? Because Friday's no school. It's actually part of a 4-day weekend for Memorial Day. So the test is Thursday, but if you want, you can do it Friday. So you could do this Thursday or Friday, but that's our plan. Okay, so here's the Pythagorean theorem. Pythagorean theorem. So named after its discoverers, the Pythagoreans. This is supposed to be Pythagoras over here. He was a teacher and he had his students. So they were the students of a philosopher and mathematician, Pythagoras. It was known as the School of Pythagoras, like around 500 BC. There's a whole interesting story about him and the secret society and how everybody wanted their knowledge. And so his students actually came up with this rule, but he got credit because he was the teacher. So his rule was this. Sounds kind of funny. The sum of the squares of the two short sides of a right triangle, has to be a right triangle, equals the square of the long side of the triangle. So here's what they discovered. When you have a right triangle, in other words, it has a perfect corner. In other words, maybe it was a rectangle and someone just put a diagonal right through it, is that we're going to call these the legs, the ones that come out of the right angle, but the long, long side that's opposite the right angle is called the hypotenuse. Kind of a funny name, the hypotenuse. Some people call it the hippopotamus. But you have to have a right triangle. And here's what they discovered. Here's a couple of jokes for you. We had this line away. How do you keep warm in a cold room? You go to the corner because it's always 90 degrees. And here's another little joke to the side you can read. Next page. Okay, so what they discovered is this famous rule. A squared plus B squared equals C squared. So easy to remember. And this is the rule. And here's a little triangle. Let's say this side had a length of 3, like 3 feet. And this side had a length of 4 feet. How long is the diagonal? Like maybe you're climbing up this ramp. Well, he says, if you take this side A and square it, and go 3 squared, and take the other leg and square it, and add 4 squared, it will equal this hypotenuse squared. So let's try it out. 3 squared is 9, 4 squared is 16. So you square each number, add them up, that's 25, and that equals C squared. So they go, well, what squared is 25? So we take the square root. The square root is the opposite of a square, and C is 5. This side's exactly 5. It won't always come out to a perfect number. Usually it's going to be a decimal. And it's proven many ways. In fact, look at the little drawing I have over here. If you took this thing right here, and you even seen this at the museum, is that if you actually drew a square right here, and since this is 3, 1, 2, 3, and made a square, and over here, I'm out of room here, but it's 1, 2, 3, 4, and made 4 this way, and made that a square. Count the little squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, here, 16, and if you made a square right here, this side would be 1, 2, 3, 4, 5. 2, 3, 4, 5. It would have 25 squares. You could take these little puzzle pieces and put them over here, it works perfectly. That this square plus this square equals that. In other words, the two little squares have the same area as the big square. So we say a squared plus b squared is c squared. And it works for any of these. So if you had like a rectangle, had this diagonal line, you wonder how long that is, you'll just square this side and square this side, and it'll equal this side squared. This is more of a little proof, and it's so famous and says, yeah, I'm kind of a big deal. This is one of the most popular ones, 3, 4, and 5, because they're nice, easy numbers. The Egyptians used it also to build their pyramids. I'm going to skip this slide, but they actually discovered it even before the Greeks did. But they used this to figure out how to get the corners perfect on a pyramid. This is actually where the actual pyramids are on a map. Now, this is the Egyptians going back even farther. And actually, if you take all these famous land sites, they actually make this right triangle that follows the 3, 4, 5 ratios. But once again, I'm just going to be skipping that. And there's lots of numbers that actually work out perfect, and the ratios, like if I doubled all these, the 6, doubled that to 8, well, this would be 10. In fact, what if I times these by 10 and did like 30, 40, and 50? Pretty cool. This is a little video. Here's a video kind of proving it. They have this actually at Balboa Park. There's 2 squares there with water, and as we rotate it, the water pours out the 2 small squares and fills up the big square. So we say a squared plus b squared is c squared. The 2 little squares add up to the big square. Once again, you empty out the big square, and equals the 2 little squares. This works for every triangle that has a right angle in it. See the little corner they labeled? Pretty cool. Sorry that it's a little bit crooked there, but there you go. Okay, so here's a problem. We've got this little right triangle, and it says 3. Get that off of there. And this side's 3, and this side's 5. What if you were here, and you were trying to walk up this ramp? Try to draw a person here. I can't. Okay, so here's a problem. We got this little right triangle. This side is 3, and this side is 5. Maybe this is a person walking up this ramp or down the ramp, you know. So here they are. It's hard to draw on the screen. How long is this side? So we're going to use these 2 things here. I'm going to use my paper here because it's easier to write. I'm going to take 3 squared plus 5 squared, and that's going to equal the long side. I'm going to use the letter H for hypotenuse. So that's 9 plus 25 is something squared. 9 plus 25 is 34 is H squared. And so I'm going to go, I'm going to go, what's the square root of this? Sometimes, if I didn't have a calculator, I would just leave and say, it's the square root of 34, or some people say radical 34 instead of saying square root. Some people even say rad 34 for short. I could put in my calculator and go, what times what is 34? Now, I know the square root of 36 is 6, and this is a little bit smaller, so I'm guessing, 34 is like 5 something. So I put in the calculator, and it says square root of 34. On mine, I got to hit the little decimal button, and there it is. So let's not write all those decimals. Let's just say 5.8 for right now. So I'm going to put a little squiggly, which kind of means I kind of round it off, means about. So it's about 5.8 is that side. That's the hypotenuse. That's how we do this. Let's try one more. Now you try it. You do this one. Get your answer. Pause the video. Okay, I'm going to do it. Let's see, 2 squared plus 7 squared. Now I know the answer's got to be more than 7. We might remember from the past that if you take 2 and 7, it's got to be, well, it can't be more than 9, because if I stretch it out, it can't be more than 9. Remember we did the thing about the biggest and smallest side? But anyway, 4 plus 49 is 53 is the hypotenuse squared. Don't say it's 53. Doesn't that seem too big, 53? Oh yeah, I got a square root. And the square root of 53, sometimes people leave it. Other times we go like this, square root of 53, and I hit my decimal, and it says 7.3, which sounds reasonable because it's the longest side. So looking at my drawing here, if this is 7 and this is 2, this has to be the longest side. So I know it's got to be more than 7. Now it can't be a million. Remember, if you just add these, 2 plus 7, that's 9. Remember we said it can't be more than 9? Yeah, I mean, it was 7.3. Okay, these are some proofs that we're not going to try to do. People come up with all these cool ways to explain how it works. I like the water. Here's some more, and they say, what's a Pythagorean triple? They call these triples, which I had on a previous slide, is ones that like, hey, it comes out perfect. Like when I do this one, 6 squared and 8 squared, I get 36 plus 64, which is 100. Hey, that has a square root. That's exactly 10. So they call these triples. And there was a slide of certain numbers that work. This is another one that works. 5 squared plus 12 squared. That's 25 plus 144, which is 169. That's where 160. It's exactly 13. So they call these triples if they work. Sometimes they say, is this a right triangle? They're wondering, is it a right triangle? Well, you got to check it out. Does this square and this square added together equal this square? If it works, it does. Let's see, 16 plus 25. We try these guys. That's 41. Is the square root of 41 6? No. So apparently this triangle is messed up. Okay, here it is in some real life. And let's see, let's try that first one there. Go ahead and figure out what the answer is. Do it in your head. Oh, it's spun upside down. And you don't like it like this, what I sometimes do. And I'm like, oh, it's kind of hard to read. I'll take the drawing and kind of like, let me turn it over. I kind of like to look at it that way. So you can just spin your head around. So make sure you're looking at the correct pieces. Make sure you're kind of going, let's see, where are the legs? Ah, that's a leg. Let's get the pen on here. There's a leg and there's a leg. The legs always have the corner, and the longest side is over here. If you just look at it, that's the hypotenuse. So 1 squared plus 2 squared. That's 1 plus 4 is 5. Don't say 5, that's too big. Square root of 5. And then I could get my calculator and go, what is the square root of 5? My calculator says it's about 2.2. So here it is in real life. I use this all the time. People use it all the time. That's why it's such a famous rule. Look at this truck. This truck is 8 foot long. This is a standard full-size truck like you see the workers using. It's designed that you can put a piece of plywood in there that's 4 foot by 8. This isn't exact. I just kind of rounded it off. It's actually a little bigger than 4 feet. Could I fit a 9-foot board in the truck without lowering the tailgate? Could I fit a 9-foot board? What if I put it diagonally and put a 9-foot like pipe in there? Would it fit? Well, let's see. How long is diagonal? Isn't this a corner? So I could do the Pythagorean theorem again. I would just kind of do my math. I would go, let's see, 4 squared plus 8 squared, 16 plus 64. That's 1670. That's 80. And now, wait, I got to take the square root of 80. Well, I know the square root of 81 is 9. Oh, it's just a little too small, isn't it? So I'm going to go square root of 80, and watch, my calculator's going to do something funny that we're going to talk about more tomorrow. And I hit equals, and it says 4 times the square root of 5? What? It's okay. I'm going to talk about that tomorrow. That's called simplifying a radical, like we simplify fractions. I'm going to show you how to do that without a calculator. Here's the answer, 8.9. So a 9-foot board won't quite fit. I'm going to put the little squiggly, which means exactly. Yeah, so it was almost good fit. Let's check out another slide. And get this out here, I can't see. A baseball field. Okay, and says, how far, and I can't see the top, how far is a throw from home plate to second base? Here's a baseball diamond, there's a baseball field. And of course, this is a guy, you run to first base, and then you run to second base. Say you were stealing base, you're running from here to here, and the catcher had to throw the ball from home plate to second base. How far is that? What do you think about it? Well, we're going to go fast here because we're online. What do I need to know first? Well, how big is a baseball field? It's 90 feet. Each one of these is 90 feet. Okay, so, but this isn't 180 feet unless I threw the ball to here and here, but I'm just going to throw it straight there. Well, that's a corner. This is Pythagorean theorem. I know it's got to be more than 90 feet because one side's 90, but it has to be less than 180 because this, if I threw it this way, then this way, that would be 90 plus 90, 180, but I'm doing a shortcut. Remember, if we add these together, that's the longest it could be. So I know it's somewhere between here. So let's use the Pythagorean theorem to get it exact. So I'll use my camera here. And we'll just write this out. Let's see, I've got 90 squared plus 90 squared. Probably just use a calculator, but it's 8,100 plus 8,100, which is 16,200. Oh, wait, got a square root. You always finish with the square root because a squared plus b squared is c squared. So I always end up with this c squared, so I'm always ending square rooting. And I know what my calculator is going to say. It's going to give me a funny radical again. It says 90 times the square root of 2. I'm going to hit 127.3. So 127.3 feet. Yeah, so that's how far it is. So it's a shortcut. Instead of walking 90 and 90 or throwing the ball 90-90, the catcher has to throw the ball 127 feet. Pythagorean theorem. Okay, you can also do these backwards. Do you think you can do it backwards? What do you think you're going to do? Go ahead, figure it out. Okay? Well, I know that the two short pieces, this one, this squared plus 6 squared is supposed to, I got the final answer. This is the hypotenuse, isn't it? That's the big answer. So instead of adding the squares, what we're going to do is subtract. I'm going to call it x as a mystery right now. Something squared plus 6 squared, and I have the final answer. This is the hypotenuse. All right, hypo for short. That's the hypotenuse. So what we just do is, instead of adding them, subtract them. Okay, so I got the big answer. What plus what is that? Subtract what squared is 13. Okay. Take the square root. So you always square the numbers, and then when you're done, you square root to kind of undo the squaring. You got to like unsquare these guys. So hit square root, 13, and my calculator said, I don't know what that is, 3.6. So does that sound reasonable? Yeah, I expected the answer to be, it can't be as big as 7, it has to be smaller. So it was 3.6. Okay, you do the next one. Okay, and if you got it, I'm just gonna go like this. I'm gonna take the big answer, 15 squared, subtract 12 squared, like that. That's how some people shortcut the whole thing. 225 minus 144, because I've got the big piece, don't I? I'm trying to find the little piece. These are the little pieces, the legs. Because I've got the hypo, the hypotenuse. So once again, probably use my calculator to subtract that. 225 minus 144. I get exactly 81. Don't forget the square root. 9. 9 is the answer. This was a perfect triple. Okay, so now we got 6 for you to do. And then I'm going to give you a worksheet for homework. Go ahead, see if you can do these 6 right now. Pause the video and come up with your answers. Okay, so here are the first 3 answers. Can't see them all. I'm going to let you in a little secret here, though. Okay, so the first one, 3 squared, 6 squared. I got radical 45. When I do this on my calculator, there you can see it, square root of 45. We say radical 45 or rad 5. It says 3 times the square root of 5. Why is it doing that? And here it says 6.7. That's what a lot of your calculators said 6.7. But mine is a Casio, and it says 3 radical 5. And that's how a lot of teachers want to see the answer. You go, why? So here's what's happening. This is called simplifying radicals. I'm going to let you know on something we're going to work on more tomorrow. To break down a radical, you know how you have a fraction, if somebody says 5 over 10, you wouldn't leave it like that. You're like, oh, I could reduce that to 1/2. It's the same with this. What you do is you got to think of, okay, 45, something times something is 45. And I'm going to say 9 times 5 is 45. The reason I chose that is because I can separate this apart. The square root of 9 times the square root of 5. Square root of 9, square root of 9 times 5 is 45. They're inside the radical, inside. Why did I do that? Why did I choose 9? Because the square root of 9 I know is 3, and the square root of 5 I don't know. We'll work more on this tomorrow. So 3 root 5 or this. These are both correct, but some teachers insist on you writing the answer like that. Or it's multiple choice, and that's the answer. Here's number 2, 4 squared, 5 squared, radical 41. This one doesn't break down. No matter what I do, I can't. The reason is, what times what's 41? Nothing. It's simplified. Okay, and number 3, did you catch on that we had the hypotenuse already? I've got the big answer. So do 10 squared is 100 and subtract the 25, 75, and go square root of 75. Once again, my calculator is going to say something different. It's going to go, you know what? 75 is 25 times 3. 3/4 is 75 cents. The square root of 25 is 5. The square root of 3, I don't know. And that's your answer. Or I could find out the decimal, 8.6, 8.7. Okay, 8.7. Okay, 8.7. And here's our last 3 answers. Okay, here's our last ones. Okay, oops, I'm going to try to get this so we can see it all. Here we go. Okay, and did you notice, oh, we got an isosceles triangle. See the marks? This is 5, so this is 5 also, because see how it's marked the same. So 5 squared, 25, 25, and I got 5 root 2, which I forgot to write the decimal in there. 5 root 2 is 7, about 7.1. Sorry about that. Next one, I noticed, oh, I got the big side, don't I? It's opposite the hypotenuse. See, it doesn't touch it. It's across from it. So I just saved myself some time and said, instead of adding, I know I'm going to subtract. I'll just go like that. 9 minus 4, radical 5. There was the other one. And the last one, number 6, just a regular rectangle. Find the longest side. I got 68. I broke it into these two. I know the square root of 4 is 2. 2 radical 17, or 8.2. Okay, your homework is to do the worksheet. And there's a picture of the worksheet on the slide, or on the Canvas assignment. To get credit, either take a picture of the worksheet. If you can't take a picture of the worksheet, type in the answer to the joke. All right, Marauder, see you tomorrow, and I'll teach you more about how do I do that.